Hey guys, Mr. Black here again. So let's talk about how we're going to solve some practice problems with Coulomb's law and what that looks like. So starting off, there are two types of charges like we said before. A little review here. Positive charge is a shortage of electrons, and negative charge is an excess of electrons. The unit of charge is called a Coulomb, represented with that big C. So equal charges repel one another, opposite charges attract one another. Like charges repel, unlike charges attract. Okay, good, we know it. Coulomb's law gives the electric force between 2-point charges. We use the inverse square law. We know that K is Coulomb's constant, 9 times 10 to the 9th. Q1 is the charge on mass 1, Q2 is the charge on mass 2, R is the distance between the two charges, and F is the force. The electric force is much stronger than the gravitation force. So if we want to, that's something important we should know. Electric force is always much stronger than the gravitational force. Okay, so let's look at an example here. We've got two charges that are separated by a distance r and have a force F on each other. So it's asking us if Q1 and Q2 are doubled and r is halved, then what is F going to be? Okay, so what we need to do here is we need to figure this out proportionally. Okay, so I've got some helpful hints up here at the top. So if the variable doesn't change, it remains constant, then what we're going to do down here with this equation is we're going to represent that variable with a 1. Okay, if the variable changes, we represent it with the number it's changing by. So over here we've got the equation, and over here in just a second I'm going to represent the variable with how much it's changing by. Okay, so let's look at what we've got here in this example. Oops, let me go back. Okay, let's break out of this. Uh-oh. Okay, so like I said before, if Q1 and Q2 are doubled and R is halved, then F is what? Okay, so what we do is Q1 and Q2 we know are doubled. K is pretty much always going to be 1. The constant will basically never change. So what we're going to do here is we're going to represent K with a 1. We're going to represent Q1 and Q2, since they're both doubled, represent those with 2's. Okay, and then R is halved. So we're going to represent R with a 1/2. Okay. So now what we have to do is just work out this math and then see what it equals, gives us a force. So on the top we know that 1 times 2 times 2 is going to be 4. So because times 1 is just 1, so 2 times 2 is 4. So we got 4 on top. And then on bottom, what we're going to end up with is 1/2 squared, which is 1/4, equal to 1/4. So we'll end up 4 divided by 1/4. Oh, this does not look great, but that's okay. So we got 4 on top, we got 1/4 on bottom. Okay, and so if we do 4 divided by 1/4, that's going to give us 16. So what we're going to end up with is that our new force is 16 times what it was before. Okay, so that is what we should end up getting. Hold on, let's see. Put this here. Down. So we did, we did 1 times 2 times 2 on top, which gave us 4. We did 1/2 squared on bottom, which gave us 1/4. 4 divided by 1/4 is 16. So our new force is 16 times as big as it was before. So let's look at question number 2 here. Okay. Put it back into presenter view. Okay, so in example 2 now, so we did a little bit of proportionality in that one. This one, let's just crank some numbers. So if we've got two 0.04 kilogram masses, each with a charge of 3 times 10 to the negative 6 Coulomb, these are placed at 0.5 meters away apart, okay? Compare the gravitational force between the two masses to the electric force between the two masses, okay? So what we need to do here is we need to use our equations for gravitation and for Coulomb's law to figure these out. Okay, so this is bringing us back old school. We're using that old school gravitation equation, and we're using the new school Coulomb's law equation. Okay, so based on these two equations that we have, what we need to do is we just need to plug in our numbers. So they gave us the mass of both objects was 0.04, so I plugged those in here. We know that the constant for gravitation is 6.67 times 10 to the negative 11. The distance between them is 0.5 meters, so we squared that. We run this into our calculators, and that gives us a really small number, a really small force for gravitation. Now let's do the same thing with the Coulomb's law equation. So our constant is a really big number here, and our two charges were 3 times 10 to the negative 6, so we plugged those in, divided that by the distance squared, and then when we run all of that through in our calculator, we're going to get 0.324 newtons. So it's a much bigger number than the gravitational force. So what we should be noticing here is that the electrical attraction is much greater than the gravitational attraction. All right, so that's pretty much how you solve these types of problems. If you have any questions, please ask your teacher. Otherwise, Mr. Black out.